Good morning to everyone. My name is LOGAPRIYA with my course number CHONG 220.2. So today we are going to discuss the question which is provided in assignment number 1. I would like to begin with section 1, question number 1. Using a suitable method to find a particular solution to the differential equation, which is d power of 2y over dx power of 2 minus 2 dy dx plus y equals to 2x power of 2 minus 1. Let's satisfy the initial condition when y is equals to 1 and x is equal to 0, and when x is equal to 0 and dy dx is equal to 2. So now let's look at the solution. So as for the solution, first we need to identify the characteristics equation, which is we need to rewrite back in terms of r. So d power of 2y over dx power of 2 is equals to r power of 2 and plus 3y over dx, which is this, is equals to 3r, and as for minus 4y is equals to minus 4 and equals to 0. As for these coefficients, we will explain it later. So we like to focus on characteristics equation first. So based on this equation which we have extracted from here, we have determined that a is equals to 1, b is equals to 3, c is equals to negative 4. So as we already determined the value of a, b and c, now we are going to put it into base formula over here, which is b square minus 4ac. Okay, this is a formula which is used to determine the amount of roots in the equation. So after we insert the formula which is given, b square minus 4ac equals to b which is 3 square minus 4, which is a, which is 1, and c which is negative 4. So after we sum up all this, we get 25. So 25 is bigger than 0, which means we have two different real roots here. So now we can assume that we are going to get two different real roots. So now we can go to the next step, which is identifying the value of the root. So once you need to rewrite back this equation over here and use the calculator to find out the answer. So when I put this in my calculator, r square plus 3r minus 4, I get the answer in this form, which is r minus 1 bracket over r1 minus 1 bracket r2 plus 4 equals to 0. So, and then when you bring this thing over here, r minus 1 equals to 0. When you wanted to bring this minus 1 over here, it will turn into positive 1. So which means r1 is equals to 1. And as for r2, r plus 4 equals to 0. So when you bring this 4 over here, you will get r minus 4. So consider this is r2 is equals to negative 4. So here we already get this answer over here, which is r1 equals to 1 and r2 equals to negative 4. So once we already determine the two different roots for this equation over here, so we can also determine the general equation for this equation right here. This one. So when it comes to two different roots, this is the general equation that everyone has to use for two different roots. So as we know, we already get the value of r1 is equals to 1 and r2 is equals to negative 4. All you have to do is substitute the value into the x over here. So we will get yc is equals to a exponent power of x plus b exponent power of e for x. So that's how you get the equation for yc. So now because we determine the value of yc, now we are going to move to the next part of this question, which is determining the general equation for the coefficients. So as you can see here, we have two coefficients here, which is tan exponent x and also negative 1250 cos 3x. So I would like to begin with the first coefficient, which is tan exponent x, power of x first. So we have to bring it out from the equation and rewrite it separately like this. Fx equals to tan exponent x. Okay, now we need to determine the general equation for tan ex. So based on the notes given by the lecturer, we have referred to this table. It states that the general equation for tan ex, the general equation for tan ex is yp1 equals to xr bracket kex. So this is the general equation for tan exponent x. So the next step is we need to make sure the we need to substitute the value of r from starting from 0 until you get an equation that states that yp is not equal with yc. So let's begin. So if r is equals to 0, let's substitute the value of r when r is equals to 0. So yp will be k exponent x. So let's rewrite this equation over here when yp is equals to yc. So yp is equals to kex equals to exponent x plus be negative 4x. So this is our yc value. You must be wondering where we get this value of yc. Well, it's from here, the equation that we determined just now. So back to the question. Okay, so once you arrange the values, which is ke exponent x equals to exponent x plus b exponent power of negative 4x, you can see that the ex on the left side and ex on the right side is equal, which means we can't use this equation when r is equal to 0. So we have to cancel out r. So we need to go for r equals to 1. So when r equals to 1, let's substitute the value of r into this equation. So when r equals to 1, we get kx exponent power of x. So this is what we get when r is equals to 1. So let's do it again. Arranging the equation when yp is equals to yc. So as we know that yp that we have determined just now, kx exponent x equals with exponent x plus b exponent power of negative 4x. So well, I can see that the equation is not same right here. Here we have x exponent x, and here we have exponent x. Here also we have exponent negative 4, the power of negative 4x. So I don't see any similarities here, which means yp is not equals with yc. So now we have reached to a point where we already determined the equation when yp is not equals to yc. So now we can continue finding the first derivative and the second derivative for the equation of yp. So let's figure out. So as we all know that yp1 is equals to kx times with exponent x. So this is our first equation, and the second equation, we can determine the second equation when we differentiate it for 1. So you will get okay, the first one is y equals to kx ex. So when you differentiate this, you will get the k, you put it outside, so you need to differentiate x first. We rewrite the x times with what you will get when you differentiate ex. You will get ex first, and then plus rewrite ex, and what you will get when you differentiate x, you get 1. So your answer is kx ex plus ex. So you will get k bracket ex plus with ex. So what I do is I simplify the equation to make it more easier. So I extract the ex out, so I'll get x plus 1. So this is the first derivative. For derivative, so determining the second order is also very easy. So you just need to use the first derivative, which is kx times x plus 1. So where your u will be equals to ex, your v will be equals to x plus 1, and your u derivative will be equals to ex, and v derivative will be equals to 1. So when you times these two, when you cross multiply these two, you get ex plus with exponent x times with bracket x plus 1. So you will get exponent x plus exponent x, which means you will get exponent x plus 2 exponent x. So which means when you extract this ex out of this equation, you will get kex bracket x plus 2. That's how you get your second derivative. So now let's move to the next slide. So once we have determined your first derivative and second derivative, you can already substitute this first, second, third equation into this differential equation that we derived just now in the beginning, together with this coefficient here, the first coefficient. So inside the value, you will get, after you substitute the value inside this equation here, you get k exponent x bracket x plus 2 bracket plus 3 bracket, substitute the value k exponent x bracket x plus 1 bracket minus 4 bracket k exponent power of x times with x. So equals to, don't forget this coefficient over here, rewrite it, and once you solve it, when you are going to solve this equation, please don't forget to expand these values over here. So once you expand and solve this equation, when you simplify it, you will get 5k exponent x equals to 10 exponent x. So when you simplify this equation, you can remove this ex already. So which means we are left with 5k equals to 10. So 5 times the k. So if you only want the k, you need to bring the 5 over here. So which means 10 divided by 5, we get k equals to 2. So once you already determine the value of k we just need to substitute back into the general equation that we figured out just now, which is yp1 equals to kx ex. So we just need to substitute this value over here. So you will get yp1 is equals to 2x exponent x. This is your answer. This is the answer for first coefficient general equation, which is yp1. So that is for first general equation for first coefficient. So now we are going to move to the second coefficient, which is fx equals to negative 250 cos 3x. So as for this one, the same thing, we can repeat the same thing over again, which is we are going to go through slide which is given by lecturer, and from the table we will figure out the general equation for negative 250 cos 3x, which is yp2 equals to x power of r bracket p cos 3x plus q sin 3x. So this is the general equation for this coefficient over here. So now we're going to repeat the same thing. We're going to substitute the value of r from 0 until we make sure that the value of yc is not same and not equals with yp2. So let's begin. So once we substitute the value of r equals to 0 into the equation of yp2, you will get p cos 3x plus q sin 3x. So we need to rewrite this equation for yc equals to yp2. You will get aex plus b exponent negative 4x equals to p cos 3x plus q sin 3x. So because I couldn't find any similarities between this both equation on the left side and the right side, so I'm going to say this is not same, which means I can proceed to the next step, which is differentiating the yp2 equation of yp2. So when I differentiate yp2, I get dy over dx is equals to negative 3p sin 3x plus 3q cos 3x. So this is our first equation, and we need to derive it again. So which means we get d power of 2y over dx power of 2 equals to negative 9p cos 3x minus 9q sin 3x. So once you already determine our yp first differentiation and also our second differentiation, we need to substitute all the three values here into this equation right here. So once you substitute the equations over here into this equation right here, you'll get negative 9p cos 3x minus 9q sin 3x plus 3 bracket 93p sin 3x plus 3q cos 3x minus 4 bracket p cos 3x plus q sin 3x equals to 250 cos 3x. Once you substitute this into the formula, you will get you need to expand it. Once you expand it and solve it, plus and minus everything, you will be left with negative 13p cos 3x minus 9p sin 3x minus 5q sin 3x plus 9q cos 3x equals to negative 250 cos 3x. So as we can see here, we have the value for cos, but we don't have the value for sine. So which means we have to assume that the value of sine is 0. So we already know that there is a value for cos and there is 0 value for sine. So we will need to extract the value of the equation. We need to extract the value of equation for cos and write it down separately. So which means we will get negative 13t cos 3x plus 9q cos 3x equals to negative 250 cos 3x. So now, once we already extract our equation for negative 250, which is okay. So since we already extract the equation half, so this is the most simplified equation which we extracted from the equations earlier, which is negative 13t plus 9q equals to negative 250, and this one you must be wondering where is the 0 came from. The 0 came from the sign, because there is no value for sign, so we assume sign is equal to 0. So negative 90 plus 32 equals to 0. And so now we are going to solve this equation by using elimination method. So as for elimination method, when we are using elimination method, we need to make sure that it's either the value of p and q shares the same value, so that it will be easy to eliminate it. So in this case, I choose to eliminate my p, so which is why I times my second equation over here with 13, which is why I times my second equation over here with 13 over 9. So I get so now I'm going to extract the equations from the slide earlier. So after I extract the equations from the slide earlier, I get negative 13t plus 9q equals to negative 250 and negative 9t plus 13q equals to 0. So this is the two equations that we have here. So I'm going to solve this p and q by using elimination method. So which means if I need to eliminate, if I need to solve this by using elimination method, I need to make either my p or q shares the same value with both equations. So in this case, I choose to eliminate p. So I times the second equation here with 13 over 9. So 13 over 9 times with negative 9, you get 13p. And 13q times with 13 over 9, you get minus 169 over 9. Q equals to 0. So when you minus this, you get negative 250 minus 0, you get negative 250. And 9q minus 169 over 9q, you get 250 over 9q. So once you solve this, you get the value of q. Your q will be negative 9. So once you have already determined the value of q equals to negative 9, you can already put it back into the equation over here. This equation right here, you can use like this equation, and then you substitute the value of q, which is negative 9, you will get p equals to 13. So once you already figure out the value of p and q, you can substitute it back into the equation of yp2, which is p equals to 13, which means 13 cos 3x minus q equals to negative 9, which means negative 9 sin 3x. So once you already determine the value of yp2, you need to make sure y is equals to yc, y is equals to yc plus yp1 plus yp2. So therefore, the value of this whole y is equals to a exponent x plus b exponent negative 4x plus 2x exponent power of x and plus 13 cos 3x minus 9 sin 3x. So I guess that's all for me, and next I'll pass it to Aisha to solve the next question. Thank you.
My name is AISHA HIKMA, and I'll be presenting the second question, which is the third question from the question paper. The question is, using suitable method, find the general solution to the differential equation d2y over dx squared plus 4dy dx equal to 5 sine 3x. First, we will have to find the characteristic equation, which is defined as the ar squared plus br plus c equal to fx, which in this question is 1r squared plus 4r equal to 5 sine 3x. Second, we will have to simplify this equation into two brackets, which is r plus 4, one bracket, and plus 0 in another bracket equal to 0, in order to find r1 and r2. By doing this, we will find our r1, which will be negative 4, and our r2, which will be 0. Next, we will use the formula b squared minus 4ac equal to 0 in order to find the type of roots. From this formula, we will get 16 as the solution, which happen to be bigger than 0, and which means there will be two roots in this equation. Next, we use the formula yc equal to a exponent m1x plus b exponent to the power of m2x in order to find yc, which we'll use in the next formula. If y equal to yc plus yp, where we find the yc, we can find yc using the formula I mentioned before, where our yc will be a exponent negative 4x plus b exponent 0x, which will give us the solution of yc equal to a exponent negative 4x plus b. Next, we find yp, and because our fx is 5 sine 3x, we show our fx is c sine beta x, which gives us the formula yp equal to xr bracket p cos 3x plus q sine 3x. Since our r is equal to 0, our yp is going to equal p cos 3x plus q sine 3x. So our yp will be p cos 3x plus q sine 3x. Next, we have to find the first differentiation of yp and the second differentiation of yp, which will be, the first differentiation will be negative 3p sine 3x plus 3q cos 3x, and the second differentiation of yp will be negative 9p sine 3x minus 9q cos 3x. Now we will look back at our original question, which is d2y over dx squared plus 4dy dx equal to 5 sine 3x. We are going to substitute y, the first differentiation of yp and the second differentiation of yp, into the equation, where we will get negative 9p sine 3x minus 9q cos 3x plus 4 negative 3p sine 3x plus 3q cos 3x equal to 5 sine 3x, where we can simplify by putting all the sine 3x in one side and cos 3x in one side, which will give us negative 9q minus 12p sine 3x plus negative 9p plus 12q cos 3x equal to 5 sine 3x. From the prior slide, we have find sine 3x and cos 3x. Now we can separate these two equations into two different equations, which will make it easier for us to find both p and q. So the equation with cos 3x will be equal to 0, and the equation with sine 3x will be equal to 5, because we have sine 3x in fx side of the equation, we didn't have cos 3x. So now negative 9q minus 12p equal to 5. We can turn the equation to positive and the negative 5 negative by taking the negative and bring it to the other side, which will give us 9q plus 12p equal to negative 5. And in the other equation, which is negative 9p plus 12q, will equal to 0. We can easily find p from this equation, which will be 12q divided by 9 equal to p. And then we can take 12q over 9 divided by 9 and put it in the other equation in order to find q. So 9q plus 12p will become 9q plus 12 multiplied with 12q over 9 equals negative 5, which will give us 9q plus 16q equal to negative 5, or 25q equal to negative 5, and q equal to negative 0.2, which we can take then and substitute in the other equation, which is 12 multiplied with negative 0.2 divided by 9 will give us the answer of p, and p will equal to negative 4 over 15. So we can look back to what we have gotten, starting from, we know y equal to yc plus yp, and yc equal to x1n to the power of negative 4x plus b, and yp equal to negative 4 over 5 cos 3x minus 0.2 sin 3x. So by substituting yc and yp into the equation y equal to yc plus yp, we will get the general solution, which in this case will be y equal to a exponent to the power of negative 4x plus b minus 4 over 15 cos 3x minus 0.2 sin 3x. That will be our solution or answer for this question. That will be it for me. Thank you.
Hi, my name is Yusvana and I'm going to explain question 5. Using suitable method, find the particular solution to the differential equation. This differential equation that satisfies the inertia condition y0 equal to 1 and dy dx equal to 2 when x equal to 0. So firstly, we need to write out the characteristic equation, which is r squared minus 2r plus 1 equal to 2x squared minus 1. So from characteristic equation, we know that a equal to 1, b equal to minus 2, and c equals to 1. So we substitute this into this b squared minus 4ac equation, and since b squared minus 4ac is equal to 0, so the roots of the equation is real and equal root, and the root will be r equal to 1. So we will get the general equation yc equals to in bracket c1 plus c2x in bracket exponential x. Just now we already find out the complementary solution for non-homogeneous part, which is yc, and now we are going to find the particular solution for non-homogeneous part, which is yp, and the equation and the part that we use in the equation is fx equal to 2x squared minus 1, and since this is secondary degree polynomial, and the yp, we will use this formula yp equals to xr in bracket ax squared plus bx plus c. This is because the function is secondary polynomial, so the solution also will use the secondary polynomial. So after that, we need to assume r equal to 0, and then we substitute r equal to 0 into the yp solution, and then we will get yp equals to ax squared plus bx plus c, and then we need to compare yp and yc. So we compare is want to check either the term in yp correspond to any term in yc. Since there is not, so we confirm that yp is ax squared plus bx plus c. After that, we need to differentiate yp equation into first derivative and second derivative, and then we label it as first and second equation. So after find out the first derivative and second derivative, we need to substitute into main equation and rearrange it. After rearrange, we will get this equation. So after we get this equation, we need to equal left hand side and right hand side of the equation. So after we equate it, we will get a equals to 2, b equals to 8, and c equals to 11. And after that, we will get the general solution, which we're using y equals to yc plus yp, and this will be our general solution. Since we have the initial condition that's stated in question, so we need to substitute into the equation that just now we obtained, the general solution that just now we obtained. Which y equals to 1 when x equal to 0, we substitute into the general solution and we get c1 is equal to minus 10. And if first derivative equals to 2 when x equal to 0, we substitute into the solution, general solution, and we get c2 equals to 4. And lastly, we get the particular solution, which is y equals to, in bracket, minus 10 plus 4x in bracket exponential x plus 2x squared plus 8x plus 11. This will be our particular solution for the differential equation. That's all for question 5. Thank you.